Thank you very much, everybody, for coming to today's webinar about architecting secure delivery pipelines. I'm Eric Kostler. I'm one of the editors over at InfoQ working on the Java queue, and my particular focus is on application security. I'm pretty interested in watching today's webinar about architecting secure development pipelines with Chinmay and Marina. To go talk through about how Harness can help organizations provide better pipelines and pick out how to defend against certain types of vulnerabilities that are pretty unfortunate for the companies that they've hit. To wrap up a couple items just of organizational things, yes, you will get a copy of the slides at the end of this. And if you have any questions, please paste your questions into the chat or send them over directly to me. And we'll have an opportunity for a live Q&A at the end where you can ask your questions either about the industry or about anything in the presentation in particular. So with that, I will turn it over to you to talk us through the presentation, and I'm looking forward to hearing more.
Thanks, Eric. Hey, everyone. Welcome to today's webinar around architecting secure delivery pipelines. My name is Chinmay Gaikwad. I work at Harness. I've been here for around 15 months now, and I lead the product marketing across AI DevOps side of things. And we also have Mrina as our co-presenter. Mrina, do you want to introduce yourself quickly?
Sorry, I think your audio is not coming through.
All right. Hi, can you hear me now?
There we go.
There we go. So hopefully this is the first and last technical glitch, but hi, I'm Mrina. I'm a senior product marketing manager at Harness as well in the DevOps team. And I recently joined Harness about a month and a half ago and have absolutely loved the product, especially in ways in which it helps you build faster and secure.
Awesome. Thanks, Mrina. So let's look at what we are planning to cover in this webinar. Essentially, we'll go through the entire SDLC through the lens of security and compliance. So if you are a DevOps person or a DevSecOps person, this is the webinar for you. We'll also understand how DevOps teams and security teams can align on the security needs of securing the entire SDLC. And then we'll also look at some of the tools and technologies and processes we need to achieve continuous GRC. We have a poll going on, so if you can take a quick minute to select one of the options of the poll. I'm looking at the results over here. It seems like a lot of people are focused on software development as well as on security and DevOps side. So we have got a good audience here, and hopefully this content will resonate with you all. All right, let's look at some of the interesting stats regarding securing the SDLC. We have seen that more than 80% of code bases have vulnerabilities included in them through open source components. Open source components are a lot in number. A lot of developers use them. I'm a huge open source proponent, but it does come with a security risk. And that's what we have seen. If it's not completely validated, open source components can be a huge security concern in enterprise companies. We've also seen 45% of organizations experience software supply chain attacks, and this is by this year. And with the boom of AI coding tools coming in, we have seen 56% of engineers commonly encountering security issues because of the AI recommended code. And this code, an instance of this code is autocomplete or tap complete features that you get through the AI assistants. So we've seen that it also introduces vulnerabilities. All right, so just to look at the software supply chain, it basically is a sum of the code, people, systems, and processes. So it's a combination of all of this. It's not a single factor that contributes to it. It's how these different factors contribute to the development and delivery of software. And that's why it is important to focus on all of these four aspects rather than just focusing on one of them or just a couple of them. If you look at the software supply chain elements, we have the application layer on the top and the CI/CD toolchain on the bottom, and securing both side of things is equally important. So on the application layer of side, this is a very simplified overview of things. So source code, OSS dependencies, software artifacts, and then eventually publishing the application live is usually the flow. And then on the CI/CD tooling side, it's your SCM provider, be it GitHub or GitLab, CI/CD pipelines, artifact registries, and then eventually the infrastructure as code pipelines. In recent years, we have seen a lot of supply chain attacks targeting both the layers. The Log4j is a great example of an OSS dependency attack. I'm pretty sure almost everyone knows about Log4j, but if you need a refresher, it basically is where attackers took control of devices because there were some unpatched Log4j dependencies, and those basically introduced a lot of vulnerabilities. It was a huge impact attack, and essentially everyone was trying to patch Log4j the very next day whenever this was announced. And
Hey,
then
Chin,
we also, yeah.
I think you might want to share your screen again. The poll has been the only slide showing up.
Oh, sorry about that.
No worries.
Okay, let's do this again.
I think we're seeing your code. There we go.
Yeah.
There we go.
All right. Okay,
That's
finally. All right, so just going back to the Log4j, we discussed Log4j, and then now on the CI/CD side of things, we won't go into the details of this because we'll cover this later, but SolarWinds, CodeCurve, Discord, Oracle Cloud are some of the examples of the latest software supply chain attacks. On the artifact registry side, Mrina, do you want to quickly touch base on this?
Yeah, sure. So we know that the SCS, the software supply chain, is under attack from Log4j to CodeCurve to SolarWinds previously, as Chinmay said. But even with frameworks in place to counter this, a lot of teams actually struggle to secure every part of it. And one area that's often overlooked or not even thought about is artifacts and artifact registries. Let's just take a look at these two quick examples, and we'll dive a little bit deeper into them later that show how these can be pretty serious weak points in your pipelines if they're not secure. So the first example is CodeCurve, where the bash uploader incident from 2021, they gained access to storage and modified the bash script. So many developers used that to upload test coverage reports. This actually tampered scripts. This tampered the script secretly and got out environment variables and credentials from thousands of environments. We'll explore exactly what the business impact was later on, but it was a clear case of artifact tampering where a trusted artifact was silently modified after it was built, but before it was deployed or used. And then there's also a report that came out from Aqua Security just recently in 2023, where researchers found over 2,000 misconfigured artifact registries that were publicly accessible, including large company registries like Google, Sonatype, JFrog, and they exposed over 250 million artifacts, some of which contain secrets and API keys and private code. So in this case, the risk wasn't from tampering, but just from artifacts being unintentionally exposed due to weak or missing access controls in registries. So to really understand these risks, we also need to look at where these risks come from. And I think the next thing we're going to be looking into is open source dependencies flowing into our code. So hand it over to you, Chinmay, to walk us through the key open source risks.
Yeah, definitely. So we've listed down top 10 OSS risks as well as CI/CD risks. We'll not go through the entire list, but we'll highlight a few examples. So one of the examples here I wanted to talk about was the risk number 3, which is the name confusion attacks. These are pretty common. A few examples of these are typo squatting, wherein a very popular open source dependency or a library is intentionally misspelled and it has a malicious code in it. So developers usually just download that without checking and use it. And in that way, malicious code is introduced into their environment without even them knowing. So that is pretty common. There are also a few other examples where a trusted author can be impersonated and whatever they produce can be consumed into the software supply chain, thus introducing a lot of malicious code in it as well.
Yeah, so when we're talking about artifacts and specifically artifacts in the software supply chain, these open source software risks also apply to that. I'm going to take a look at probably the number one most common risk with artifacts, which is the compromised legitimate artifact packages, OSS risk 2. It's one of the most common and dangerous threats right now, which is the compromise of trust packages. For example, like an attacker might steal a maintainer's credentials and publish a malicious version of a package, so thousands of developers rely on. From the outside, it literally looks like a legitimate update, but inside there is code that's waiting to be triggered to take out secrets or environment variables. This type of supply chain attack is hard to catch and pretty effective. Since you trust the package, you trust the pipeline, and you trust the build as well. So the malware does slip right into your environment or your product. There's also a few other vulnerabilities like known vulnerabilities with OSS risk 1, where using artifacts that contain dependencies with publicly known vulnerabilities is basically, leaving your front door unlocked and giving them your address. And things like untracked dependencies with OSS risk 6 or unmaintained software, where if you no longer support or patch your artifacts, you do leave yourself to an exposed version. The big takeaway here with all of these open source software risks is that every artifact that you bring into your development lifecycle, whether it's open source libraries or container images, they should be treated as a potential attack vector. You really need visibility into what's inside. You need control over what gets approved and automation to enforce the best practices at scale. So if you're not actively managing this, it's not a matter of if you're going to be compromised, it's basically when. And I'll hand it over to Chinmay to walk us through the top 10 CI/CD security risks.
Yeah, so similar to the OS risks, we also have a lot of CI/CD risks that OWASP has defined. So some of the examples here are insufficient flow control mechanisms. It basically identifies who has access to which part of your SDLC. So it can be a developer or a person you hired as a contractor, and which tools do they have access to, for example, SCM, CI/CD, or artifact registry. The second one is essentially the identity and access management permissions, and that basically signifies what do they have access to. So an example would be if a developer has access to PAT, then should they actually have access to that particular PAT or SSH keys, for example. Then there are others wherein they're a little bit more complicated. So poison pipeline execution is something that we have seen quite a bit. It basically is who can push the code into the CI system from an SCM. So they necessarily don't have to have permission to CI/CD, but if they have access to SCM, they can push a CI config which contains some malicious code. It can be either downloading some unchecked dependencies or something else, but they can basically pollute the entire pipeline, and that's why it's called poison pipeline execution. And then the other one that I wanted to quickly touch base on was insufficient PBAC, which basically means a pipeline has different components: build, test, deploy, for example. And what permissions does the build stage have? Can it push into a Git Git repo? What permissions does a test stage have? Can it push and pull from a Git repo? And all of those things. So the common advice here essentially is start with the least privilege model. So you give the least privilege to each system and each actor in the SDLC. And in that way, you can upgrade the permissions if required, or you can keep it as is. And it essentially helps you keep secure. Nalini, do you want to talk about the artifact side of risk from a CI/CD perspective?
Yeah, I mean, artifacts are basically everywhere in our pipelines. And as I said before, if we're not securing them properly, they're becoming a major attack surface. There are 3 risks here in the top 10 CI/CD risks that I'd like to call out where artifact security plays a central role. The first one that is most common is the CI/CD Sec9, which is improper artifact integrity validation. This one is pretty straightforward and honestly one of the most critical ones. It's basically that if you don't verify artifacts like container images, binaries, even internal libraries, we have no guarantee that they've even been tampered with. So whether it's a missing checksum, no signature validation, or skipping content trust altogether, that's really how malicious artifacts sneak in and end up in production. The second one that I'd like to call out is CI/CD Sec3, which is dependency chain abuse. We already talked about compromised packages earlier, but this becomes even riskier in CI/CD. Let's say you're using a pre-built image or a library someone published. If that artifact brings in like hidden or malicious dependencies, and you're not scanning or verifying it, the risk multiplies very quickly. So all it takes is one compromised artifact to bring in dozens of downstream vulnerabilities in this case. And finally, the other one is CI/CD Sec10, which is insufficient logging and visibility. This one's all about traceability at the end of the day. So if someone swaps out or modifies an artifact during your pipeline, and you don't have logs or signatures to track it, you're basically flying blind. There's no way to know who changed what, when, or why, and that makes the incident response and root cause analysis really difficult even after the fact. So basically, to wrap it up, these risks make it clear that artifact integrity, visibility, and dependency hygiene aren't just best practices, they're basically security fundamentals today. I'll hand it back to you, Chinmay, to discuss the SolarWinds attack. And
Yeah, so just to focus on a couple of supply chain attacks, one of them was pretty popular for not so good reasons, the SolarWinds attack, which happened in 2020, 2021. It essentially was a CI/CD complicated attack, and the attackers essentially exploited misconfigured CI/CD pipelines and placed malicious code in it. And the customers of SolarWinds who legitimately downloaded the upgrade to the Orion software got impacted by this attack because whenever they downloaded the upgrade, the malicious code became active and got access to the customer's information. So this was a huge attack. The other one was for Discord, where it impacted around 100 to 200,000 developers. And this was another complicated attack where attackers used GitHub repos and placed malicious dependencies, which basically stole sensitive information from the developers. We also have a lot of attacks on the artifact red side. And Rina, if we can talk about the CodeCov one.
yeah, so I think I briefly highlighted this before, but in 2021, CodeCov actually, which is a popular code coverage tool, it was breached when attackers exploited their Docker image build process. So they basically tampered with Bash uploader script and added just honestly one line of malicious code that infiltrated secrets from every pipeline that used it. So the impact was actually massive. 29,000 organizations were affected. Companies like Mercari saw customer data compromised. Others like Twilio, HashiCorp, GoDaddy, and even the Washington Post had to rotate secrets and audit systems and harden their pipelines. And it all stemmed from this single trusted artifact that was modified after the build. So Code made it pretty clear that if you don't verify your artifacts, you are flying blind in your build process. And we've seen this pattern actually repeat even more recently. In 2024, attackers replaced Kong's official Docker Hub image with a crypto miner. And that same year, TopDG, a major Discord bot platform, had a package compromise that leaked bot tokens. And in 2025, I think widely, and that was earlier this year, widely used GitHub action, which was TJ Actions, was backdoored, and they stole credentials across thousands of repos. And this just goes to show that in each case, trusted artifacts are silently compromised and distributed. And in each case, the lack of artifact verification just left thousands of customers and companies exposed. So just moving on to the next slide. So how do you get to this? So how do you get to a more secure state? So to achieve basically continuous software supply chain governance, risk management, and compliance, you really need a strategy that basically spans across governance, visibility, and actions. So the three components that we have here are policy-driven governance. It really starts with policy enforcement. You need to define and apply policy across your CI/CD pipelines that align with established frameworks like CIS benchmark. We talked about OWASP's top 10 risks and SALSA, which we'll talk about soon. And this also means that you need to be pinpointing risky behavior in your tool chains, blocking non-compliant actions, and automating enforcement, not just surfacing the alerts. This will really make sure that teams can move fast without bypassing all the controls. The second thing is understanding your current state with CI/CD security posture management. You need full visibility into your CI/CD pipelines, OSS dependencies, and artifacts, especially how they stack up against your compliance and risk standards. So this includes SBOMs to track open source components, SALSA compliant artifact promotion to verify the integrity, and a full chain of custody for every artifact, so you know what's running and whether it can even be trusted. It's really about proactive posture management here and not the reactive sort of forensics that we've been seeing across some cases. And finally, there's remediation. You need to be able to take action to fix what's out of compliance, whether it's removing those high-risk OSS packages, blocking promotion of unverified artifacts, or stopping zero-day vulnerabilities from moving downstream. You do need to be able to remediate risk immediately with traceability. So this is where continuous supply chain security comes to life, not just identifying issues, but closing the loop with real controls and automated responses. Let me hand it back to Chinmay, and so that we can see how this would work across the life cycle.
Yeah, so just for the sake of simplicity, we'll be considering this SDLC, which starts with the IDE, brings in code repos whenever a developer commits the code. Then the CI/CD pipelines kick in whenever a pull request is created. Then we create an artifact out of it, and then finally deploy that particular artifact. So what we recommend is essentially starting with securing each stage of the SDLC. So right from the left, IDE, code repos, build, artifact registries, and then deploy, securing these individually. And then we recommend coupling 2 or 3 of these stages together and then securing them as well. So in this case, it would be IDE, code repos, and build, or it can be IDE, code repos, build, and artifact registries. And then finally, we secure the entire SDLC. So it becomes a very granular security strategy. And let's look at some of the examples of how we can achieve this. So for IDE, for example, what we recommend is using pre-configured cloud development environments, which essentially is you use a secure cloud to spin up an IDE, such as Visual Studio Code or something like that, which is completely within your control. And you can set proper RBAC permissions for it. And then you can also run security scans, essentially, which are compliant to your policies. This not only helps with developer security, but it also helps with if you onboard a new contractor, you can also give them the right permissions so that they don't access what they shouldn't, essentially. For code repos, we recommend using branch protections and approvals, and then definitely shifting security to the left, which means secret scanning tools are integrated pre-commit. Even SAST scans are done pre-commit, and SCA or open source dependency scanning is also done pre-commit. And then essentially also having RBAC and audit trails so that you know which code was changed or which code was committed by a developer, and then when did they commit it and what was the diff between the previous commit and this commit. This kind of security would definitely help with the poison pipeline execution that we talked about. Just a reminder, the poison pipeline execution essentially was anybody having an access to an SCM can pollute the CI pipeline because they can also upload a malicious CI config file, thus triggering a malicious CI/CD pipeline. On the build side of things, again, orchestrating security scanners are very important, and we recommend using more than one security scanner. Each security scanner has their own pros and cons. So using a combination that works for you is essentially important. And then orchestrating them, figuring out how you surface vulnerabilities to developers, deduplicating the vulnerabilities is extremely critical in this case. If you're using a hosted build environment, making sure that you create a secure tunnel to that infrastructure. If you are using self-hosted ones, also making sure that self-hosted infrastructure is also extremely secure, and then making sure SALSA level 3 compliance is visible for the builds. And when I will go into the SALSA level 3 soon, but SALSA level 3 is the highest level, and just making sure that the build complies with it is extremely critical. And then eventually using templates, wherein you have all of these security policies and governance rules integrated into a single template, so that whenever a developer or a DevOps engineer creates a new pipeline, they use the template rather than creating a pipeline from the scratch. Just a quick tip, scanners are not slow, so just use extremely fast scanners. And as we all know, developers have very little patience for security scans. And today you have a lot of scanners that run within a few seconds or within a minute or so. So definitely recommend using those. And this kind of a security measure would essentially help prevent dependency chain abuse. And I'll let Mrina talk about the software artifact security.
Yeah. So as I've probably drilled many times, securing the artifact is a critical part of SDLC, but often overlooked. Even if your code and pipelines are secure, the artifact itself can be tampered with after build. And we did see this previously with that Code Cove incident and many other incidents that followed. So that's why we have 4 core controls on this. Number 1 is artifact integrity. The artifact you deploy should be exactly the one you built and approved. So no changes, no swaps, just that artifact. The second part is authenticity verification. Artifacts must be signed and verified to ensure where they came from and whether it was a trusted source, and that signature needs to be unique to that specific artifact. The third, and I'm going to be talking about this more later on as well, SALSA, which is provenance tracking. You need a traceable record of where and how the artifact was built, just so that whether there is a vulnerability in the future or as your pipeline is maturing, you are able to catch if there has been a new build, or if there has been a new build and it was a new artifact and that's what you're deploying. And finally, there's artifact scanning. Before promotion, you need to inspect every artifact for vulnerabilities and secrets. And there are a few scanners available externally as third party. And then the other 3 are, of course, covered by most software supply chain security standards, including the one that Harness provides. Next slide, please. And then after artifacts, basically the final step is making sure that we deploy everything securely. There are 4 practices to make sure that deployments are secure. The first is to test it technically from both angles, right? Most teams scan code early in the pipeline to find issues before the build, and that's called static analysis or SAST. But once something is ready to deploy, you also want to test how it behaves in the real world. And this is dynamic testing or DAST. Running both types of scans will actually help you catch issues early and before they reach users. The second one is putting approvals in check. Basically, before anything gets deployed, having an approval step in place. This can be as simple as a lead developer or security engineer signing off. It helps catch anything risky before it goes live. The third, it's something Chinmay also mentioned, is using templates instead of one-off scripts. Templates just make sure that your deployments are repeatable and they're secure. And they reduce the chance of someone accidentally introducing a misconfiguration or skipping a security step. And finally, you need control of who can ultimately deploy. Not everyone should be able to deploy to push code to production. That's where role-based access control or RBAC comes in. It lets you set rules for who can deploy, where, and under what conditions. All of these steps add up to one goal, ultimately making sure that only secure and approved and tested code make it into production. But the question is, how do you make all of this repeatable, provable, and trusted by design across the entire supply chain? And that's where Salsa comes in. Next. So Salsa, it's short for supply chain levels for software artifacts. And it's an industry standard framework built to help companies protect against tampering and make sure that there's artifact integrity. At its core, Salsa, it's all about provenance, which is basically knowing exactly how, where, and by whom an artifact was built. It defines 3 levels of assurance, and each level builds on the previous one to give you sort of stronger guarantees. Level 1 is about starting with the basics. So just generating some build metadata, even minimal provenance is better than none. So making sure you have some build metadata is always good. Level 2 is linking artifacts to specific systems and identities, so you can trace a build back to the exact machine and user that created it. And level 3 is where the highest level of trust kicks in. That's where Harness is at as well. It requires strong security controls like 2-person code reviews and isolated reproducible builds. That just means that every build is locked down, verifiable, and nearly impossible for attackers to tamper with. But here's really the important part. Provenance is only valuable if you actually use it. It needs to be verified and enforced as part of the software delivery supply process. So I will hand it back to Chinmay to take it from here and walk through some of the key objectives and how they map across the pipeline.
Yeah, so as I initially mentioned, not only securing each stage of the SDLC is important, but also coupling the stages is also important. And if, for example, if you couple build artifact registries and deploy stages, you can handle vulnerabilities like insufficient control mechanism. In a similar way, you can also handle improper artifact integrity, validation vulnerability. And then eventually, once you secure the entire platform, you can basically handle the inadequate identity and access management vulnerability. We have seen a common theme across these different stages, and RBAC, audit trails, templates, etc. are extremely important in all the stages. So that's why it becomes important to use a platform that has all of these features natively built into it. And I'll talk about these 3 features essentially, which I feel are really important to have in a platform: a policy engine, a very granular RBAC, and then audit trails and logging. So basically using policy as code, one of my favorite open source projects is the Open Policy Agent project, where you can use a regular language to create policies that are very specific to your organization. And policies can be as simple as using a particular scanner or something like that. So definitely leverage such open source projects to create policies that are specific for your organization. RBAC, having a granular RBAC is extremely important. As we saw, what and who are the two things that you need to take care of. So essentially creating a matrix of who has access to a particular resource and what level of permission do they have access to can be achieved using granular RBAC. And then finally, it's very important to keep track of changes, be it if you're in a regulated industry, it's almost mandatory for this. But even if you're not in a regulated industry, having audit trails is extremely important so that you can track down what changes were made, and you can also effectively roll back to a particular change that affected the security of your SDLC. Talked about the open policy agent a bit, but essentially this is what it looks like. The Rego rules are very simple. An example here is you have a required step as a Wiz scanner in your CI/CD pipelines. And if a developer or a platform engineer actually does not have Wiz scanner in their pipeline, then the pipeline doesn't execute. In that way, you're protected and you set guardrails essentially so that all the pipelines follow your basic policies of the organization. It's very easy to learn, and even if some of the policies creation can be tricky, these days there are a lot of AI tools available out there which can essentially help with creating these OPA policies. Okay, so just to sum everything up, we talked a lot about how we can secure each stage of the SDLC, right from coding securely to building secure build pipelines, to securing artifacts as well as securing deployments, and then what a platform should have in order to support all of these security measures. And we talked about OPA, we talked about RBAC, as well as audit trails. This basically summarizes everything we talked about pretty nicely on one slide. But there is one more feature that we need to talk about, which is AI. No webinar today or no piece of content today can be complete without talking about AI. And let's see how we can leverage AI in this security and governance world. One of the use cases for AI is essentially finding out what vulnerabilities exist and explaining them to the developer as well as creating fixes for them. So as I mentioned before, it's very important to have more than one scanner in your SDLC because each scanner has different pros and cons. But the vulnerability surfaced by each scanner can be duplicate, and it can be very cumbersome for a developer to actually figure out which ones are duplicates and which ones are not. AI is really good at figuring out how to dedupe these vulnerabilities so that you can get one version of a vulnerability and not multiple versions of it. Then you can also highlight code using AI, which basically explains what vulnerability is and how it will affect a particular piece of code. Developers are not meant to be security experts, so for them to understand what a poison pipeline execution is would take some time, but AI can really make that job very simple. And finally, creating a autofix, or at least creating a foundation of an autofix that the developers can actually use and easily publish it so that you can actually shift security to the left is extremely important as well. But with AI, there is also a challenge of compliance. So at a very high level, it's basically treating AI as any other actor in your SDLC. So basically, a user goes through the same governance model if they are allowed to do a particular action. And then the AI is also goes through the same governance model. And if both of them have the permission, only then a particular action is permitted. A good example of this is, let's say a user wants to create a pipeline and they use AI to create a pipeline. So first of all, the user should have the permission to create a pipeline. And then secondly, the AI should also have a permission to create the pipeline. And these all can be enforced using a policy engine like OPA. So that's most of the things that we wanted to cover today. Rina, do you want to summarize what we talked about?
Yeah, sure. So thanks for listening to us. But if there are three things we hope you take away from this, it's these three things. So first, secure every part of your software supply chain, not just the code and pipelines, but dependencies, build systems, artifacts, and registries. Everything is part of the attack surface. Second, use frameworks like Salsa to verify artifact integrity and SBOMs to quickly identify and respond to those day zero vulnerabilities. And finally, embed compliance into your pipeline with policy as code. And don't wait to bring AI into your governance model. Just make it part of your foundation from day one. These three things, visibility, verification, and proactive governance, are what will help you fundamentally build secure, resilient pipelines at scale.
Awesome. I just wanted to leave with this basically, which is Harness has a lot of these features, but feel free to try it out using a free account at harness.io. We also have a web page which basically summarizes all the things we talked about as a solutions page, and this is the link to it. And with that, we can open it up for Q&A.
All right, so thank you guys very much for that. That was very informative in terms of walking through all the risks and mitigations associated with an SDLC and the ways that people can compromise just anywhere along the path. So one of the questions here asks about, can we get some CI/CD code samples to implement these practices?
Yes, definitely. I can probably, when we send a follow-up email, Eric, we can probably send a sample code pipelines so that they can be implemented.
Okay, and what do you see in terms of the systems that people need to secure? Is it regularly, are there certain pipelines that you see more often than others, or what are some common paths that people have to follow with these?
Yeah, so what I have seen is there is usually a pipeline sprawl whenever a team starts creating a particular piece of software, the developers start writing the code, and the pipelines are created for that particular project. But what we recommend is using templating from the start, and these templates are pre-approved by your platform team, and they have all the security measures integrated into it. So whenever a developer creates a particular pipeline, they should be in compliant with the template. In that way, you set like guardrails for your organization, and the developers can be as creative as flexible within those guardrails.
All right, so you mentioned the role of the open policy agent, of that being a thing that you just generally like to see. How does the open policy agent fall in line with templates, or are those different activities?
They are they can be combined together. They can be separated out as well. One of the examples of a combination is when you create an open policy agent policy, you can actually tell the policy to use a specific template. In that way, templates are mixed with open policy agent. But if you have to create a different policy, which an example of which I talked about was adding a security scanner within a pipeline, you can also separate them out. It depends on which use case you're using it for, but both approaches are equally viable.
All right, and then can we talk a little bit about roles and responsibilities? Because in an organization, in a development team, there's a lot of people who are associated with different actions across the SDLC. Like for InfoQ, we tend to have a lot of developers and architects, which I saw was about 2/3 of the people from your poll. So what happens between an individual developer who's working on an application or an architect, and what role does each person have in terms of securing the SDLC?
Yeah, that's a great question. And depending on the organization, the roles vary quite a bit. But what we have seen, I used to work for an application security company before, and one of our biggest things was, even though our target audience were security professionals, we really wanted developers to understand security as well as fix vulnerabilities. Obviously, they don't need to be experts in it, but they should have a certain level of understanding of security. So what I'm trying to say is essentially everyone is responsible for security, but the levels are different. Ultimately, the security team or the DevSecOps team is the ultimate authority on this, but it's up to them on how the knowledge is disseminated down the pipeline, be it developers or any other persona.
Okay. Are there normal conventions of who's responsible for what? Like, at what point does an individual engineer within a team need to delegate to another group, or how do they identify gaps of something where they think it might be covered by the other team, but it's actually their responsibility?
Yeah, I think just to start from the top, shifting security left is extremely critical. So we talked about having security scanners pre-commit, and whenever a developer commits the code, a security flag can be raised if there's a vulnerability in the code. Now it's up to the developer to fix that vulnerability if it's a critical vulnerability. And this is where organizations can set policies wherein they can say that if it's a critical vulnerability, you can't really push the code in a code repo. So that responsibility leads with the security team. And then the developer, it's up to the developer to fix the vulnerability. And the second part is, if they don't really understand the vulnerability, the security team again is responsible for making sure that they use AI or something else to make sure that the developers understand the vulnerability, the impact that the vulnerability would have, and then make sure that they are fixed.
All right. And one of the things that happens in a CI/CD pipeline is feedback from production. So let's say we are monitoring something and there's a new type of attack that maybe somebody wasn't watching for. Are there any types of feedback loops here that say, hey, it turned out our previously what we thought was secure, it turns out it was breached? Or what are signals that we can use coming back from production systems?
So essentially, what you're talking about can be a zero-day vulnerability, where you can say that like this package was secure, but today this package might not be secure. Those ones are really tricky to identify and fix for obvious reasons, because the patches might not be available right now. So the only way you can basically security teams can take control of this situation is by saying that don't use this package. And I know it's not a very practical option in most situations, because a package like Log4j is extremely critical, is being extremely widely used, but it is also extremely important that we don't use malicious packages until they are fixed. So having a workaround around those or patching them would be the two options that you would go for. And it might have some business impact, but that definitely saves the business from having a bigger impact like SolarWinds or some of the examples that we have seen.
All right, another question that came in is, should release pipeline and dev pipeline be different? Or what do you see as differences between people who are having a pipeline that releases into a QA environment or a pipeline that actually releases to production environment or customer accessible areas?
Yeah, that's a great question. I think I'd go back to the templating aspect of things, where we can have a pipeline that builds a certain piece of code, that deploys it to QA, and then that deploys it to production. So you can have like a really long pipeline, which is approved by our DevSecOps team, and use the same template again and again over. The only caveat is certain use cases might be edge cases wherein you have to create a different pipeline, but we strongly recommend using golden pipelines or golden templates, as we call it, so that the pipeline sprawl is not too much, and you can actually monitor these few 10 or 15 pipelines that you have been using. We have seen customers actually come down from 10,000 pipelines to 100 pipelines in one instance, and that really helps them like manage those pipelines very effectively.
That's a trend that we've been seeing generally in the industry from InfoQ surveys and conversations with people, is the notion of the golden pipeline, the paved path, or a strategy by which you have the path that almost everyone does that follows you into success, versus everybody going off and creating their own variation of a pipeline with a tiny change.
Mm-hmm. That's right.
Okay, so essentially bridging from fewer paths to having common shared templates is one of your big recommendations here.
Yeah, definitely. That's definitely top number one or number two, I would say.
Okay. Are there any other general tools that you recommend people take a look at to apply to their pipelines? Or in terms of signatures, are there any signature applying tools like Java has jar signer? Are there any particular package mechanisms that you recommend people apply those signatures with? Or even where did the cryptographic keys come from?
Yeah, I'll let Meera talk about the package signatures, but just in terms of different tooling, I think what we have seen is a trend of, so obviously organizations use SBOMs right now, and they monitor which software is being used in the delivery pipelines. But we have also seen a concept of AI bombs or artificial intelligence bombs. So if an organization is using a lot of AI tools, what are the entities that are being created by these AI tools should also be in the AI bomb. And those also need to go through the same rigorous software or security procedure that the SBOM needs to go through. So that's definitely one of the trends to keep an eye on. And I know a lot of startups are working on that as well.
Yeah, I can take the question on signing artifacts and signing signatures. So essentially, as you said, there are individual to, depending on what you're working on, if you're working on RPM or Debian tools, then, you can sign it with GPG. If you're working on there's things like cosign out there for container images and binaries that are very popular. I think Notary is also really popular, especially for like OCI artifacts. So there are tools specific to artifacts and certain images and binaries. And then of course, if you're using Harness, our SCS feature can actually automatically sign artifacts, specifically container or non-container during the build, and verify signatures before deployment as well. And then with just tying it all together with OPA-based policy checks, you can also add in a specific policy that you only deploy if it's signed by this specific key. And that can integrate into specific tools like cosign, notation, GPG behind the
Okay, and the OPA term that you mentioned, that was the Open Policy Agent?
Yeah.
Got it. All right, let me see if we have any other questions here. I don't see any new questions coming in now, so anyone who wants to ask a question, feel free to ask some. Otherwise, yes, we will be following up with the slides, and we will be following up with a couple CI/CD examples. Are there any common misconceptions about secure CI/CD pipelines that you see that you want to correct in advance?
That's a good one. Misconceptions. I think it depends on the organization, to be honest. But I think can't really think of something at the top of my head. Mrina, do you have any examples you can think of? Specifically on the artifact side of things.
Well, one of the things I commonly see is like a security theater where people do a particular ask in the name of security, but then you look and you say, what does this actually do? And it doesn't actually do anything. It just chews up a lot of work.
Yeah, I think that's where the developer and security team confidence comes into the picture. And I think that's like, from a cultural perspective, what I've seen in my past life is that's a really big problem to solve. Developers really don't trust all the security vulnerabilities being exposed to them, or if they really need to be fixed or not. Even if it shows it's critical, the impact radius might be smaller. And I know a lot of products out there are trying to figure out how, if like, what's the definition of actually being critical? Is it just OWASP defining it as critical, or is it actually having the impact on your code, on your software delivery pipelines? So there is a variation of all of these things, but I think it depends on the organization on if they want to comply with OWASP or if they want to comply with the impact of a vulnerability on the particular piece of code. And the latter approach I see is winning quite a bit than just like following specific frameworks blindly.
Okay, so your preference is which of the two?
The second one, the latter one, which is the impact of a vulnerability on your CI/CD pipelines or the code.
All right. With that, we are coming up on time. So are there any aspects you want to leave with before we send everyone a copy of the slides and materials?
Nothing much apart from saying that AI is again also impacting a lot of these things. So definitely trends from Gen AI and how we can secure AI produced code, AI produced pipelines and stuff like that will be critical. So that's a good trend to look out for.
All right. Sounds excellent. All right. Thank you very much, everybody, for attending and watching today. And I really appreciate the presentation. Have a wonderful afternoon.
Thanks all.
Thank you.
Thanks, Eric.